Hello, Algebra 1. Here we go. Chapter 6, Extra Credit. So, when you're trying to determine if something is a solution, that means it's going to work in not just one, because this is, remember, a system of equations. It's got to work in both. So we have to literally go off here and substitute these in. So this is my x, this is my y. And we're going to set it up so that I have one equation there and one equation there. And we're going to substitute the x and the y's in and see if what we end up with is true. You're going to get a number equals a number. Is it the same number or are they different? True or false? So here we go. 2 times negative 1/2 minus, make sure you put the parentheses in on that, otherwise you're going to end up subtracting that accidentally, equals negative 2. 2 times negative 1/2, 2's cancel, right? Left with a negative 1. Minus 1 equals negative 2. Negative 1 minus negative 1, negative 2 equals negative 2. Yay! That is definitely a true statement. Negative 2 is definitely negative 2. Let's go check this one out. 1 minus 4 times negative 1/2 equals 3 again. If you forget the parentheses, you might be inclined to do 4 minus that. So put your substitutions in parentheses to prevent errors. 1, and then it's a negative times a negative, so it's going to end up being a plus. And 4 times 1/2 is, of course, 2. 1 plus 2 is 3. Is 3 equal to 3? Yes. So since they both work, my answer to the problem is a nice, bright yes. Oh, I just don't like that y. That really bothers me. Let's get a nicer y in there. There we go. Fix that up. All right. Now, when we get to, so that was one solution for this, for these two equations, and that might be all there is if it's just two lines that cross in one place. So there's different ways we talked about. We talked about graphing, substitution, and elimination. So the next three problems have you show me that you know how to do all of them. And no matter what you do here, you're going to be solving equations, all of them almost, for y. So that is crucial. If you're having trouble solving, we need to get a handle on that. So I'm actually going to take each of these so I don't run out of room and make mistakes. And I'm going to move down here and solve them. So I'm going to rewrite them. Okay, I'm going to draw a line, add 2, y equals, I cannot combine those, they're not like terms, 1/3 x plus 2. Okay, so I have one equation ready to go. See, slide that up a little. And we're solving for y. And so I don't have anything to add or subtract like I did here. I just have to divide by 3. But again, remember every term gets divided by 3. So then the 3's give you 1, y. And we usually put this in the front as a fraction, and with the x following. And then 3 over 3 is 1. So good, I've got them both. So now we just need to graph them. So for this one, I'm going to graph this one in pink. Up here, y-intercept is 2. Slope is 1 over 3. So I'm going to rise 1, run 3. 1, 2, 3. And if it's hard for you to figure out the line because they're so close, you can keep going. Rise 1, run 3. So that you have 3 points to line up. Okay, connect it. Always using a straight edge. I'm going to label that line. All right, let's do this one in green. And y-intercept is -1. So go down there. And then the slope is a -2/3. So I could either put the negative with the 2. So that would be down 2, run 3. Right there. Or I could put the negative down with the 3 and do rise 2, run 3, negative. Ooh, which happens to be my intersection point as well. So we need to line these up. And I'm going to label it. I'm still not done. I hope you guys know that. I've done all this work, but I have not sealed the deal. So we need to find our solution because it says to solve. My solve is right here where they cross. That is the solution, and that is what? -3, 1. So right up here, I put -3, 1, and that is my answer. Okay, so that's graphing. I know all of you really liked graphing, and I'm not being facetious. You guys actually were really good at graphing. And I'm having trouble sliding my paper for some unknown reason. Okay, let's go to this. Now it says solve by substitution. In order to solve by substitution, we need to replace something. So first I want to analyze what I have. Okay, I don't have either variable alone in here. But in here, look at, I have the x alone. So remember, it doesn't always have to be the y alone. Sometimes, and most of the time actually, it works out to be that way. But it's already set up. So I don't want to solve for y. You could solve for y and then substitute the y in, but we don't have to. We have this is x. So I'm going to go up here and replace my x right there with y minus 12. I'm just going to be careful to make sure I put that in parentheses. So I'm going to rewrite it and have -2x minus y equals, uh-oh, hello green pen. Green pen. Oh no, my dear green pen has bit the dust. Must have been all the Christmas cards. All right, lime green, you don't look so nice. Let me try purple. Ah, there we go. Now we're talking. Okay, so back to this. I'm taking my x out and I'm putting what x is equal to in. So I'm going to take my x out. So does everyone see? I have the exact same equation right here, but I'm taking this out, and instead I'm going to put the other side in, y minus 12. In this case, you need to make sure that you, what do you call it? What do you call it? Distribute. Thank you. I don't know who I'm thanking. Anyway, -2 times y is a -2y. -2 times -12 is a positive 24. Watch your signs. Minus y equals 3. I've got like terms over here. So I'm not moving anything yet. I'm just combining like terms. So -2y and a -1y is a -3y. Plus 24 equals 3. Okay, next step, subtract 24. Again, watch your signs. Don't lose this negative out front. And make sure you add this correctly. Positive 3 and -24 is a -21. Divide by a -3. And y is equal to 7. Not done. Solve. Solve is a coordinate. But I got to be careful because this is a y. So don't accidentally put it in the wrong spot. That's my y. And now I just need to rewrite take my bottom one here. Well, you can take either one actually. I just see that x is equal to this, so it looks super easy to substitute. So I'm going to substitute again the 7 in for the y. And x is equal to, what is 7 minus 12? It's not 5. Negative 5. There's your answer. Negative 5, 7. Okay, next one is solve by elimination, the third method you learned. So again, analyze, look at this, decide, do I have it? Remember, there's 3 different difficulty levels. There's one where it's set up super slick, and you can just add down and like the y's or the x's drop off. Although it is set up nice because you have the y's and the x's together and the numbers and everything, you don't have to solve. They're in standard form basically, but nothing's going to drop off. If I add these, I'm going to get 5y, and if I add these, I'm going to get 1x. So not very helpful. So I need to get rid of 1. Now if it was just a sign difference, I could just multiply by a negative 1, but in this case, there's no easy one to pick. Except that this is a subtract and this is a positive. So I'm going to get rid of the x's because of this. Doesn't matter, but you're going to multiply this one by the 5 and this one by the 4. And you don't have to worry about the sign because of them being the opposite already. So now we're going to rewrite those and just multiply. So 5 times the 3y is 15y. 5 times the negative 4x is a negative 20x. 5 times the 29 is, what is 5 times 29? Why am I doing, oh, I did the bigger one. On the answer key, I did use a smaller one. That's okay. That's okay. 145. Multiply the 4. 8y plus 20y, or 20x equals 16. Now it works. This drops out. 15y plus 8y is what? 23y equals 145 plus 16 is 161. I'm going to divide both sides by 23 and hope it comes out even. Let's see. 161 divided by 23, 7. Good. So I've got half of it. So pick either equation. I'm going to pick the bottom one. And I'm going to substitute in the y. So we have 2y plus 5x equals 4. I'm going to substitute the y in. Subtract 14, subtract 14. Divide by 5, and x is a negative 2. I was about to say any questions, but I guess it'd be a little hard for me to hear you. Okay, onward we go. Robin has $24.50. She just has that. And her brother Wayne has $68.50. Her brother Wayne is paying her $2.75 each day to help with chores. Okay, so he's got the most money, and he's going to be giving her that much to help with his chores. My brother used to do that, actually. He used to pay me and my other brother to do his chores. But anyway, when will they have the same amount? So let's figure them out. We need to get 2 different equations, don't we? We have Robin. I'm going to do R for Robin. And we have Wayne. All right, so what is Robin? Robin has the $24.50. And what does Wayne have? $68.50. But now we need to work this other part in. It's $2.75 for each day of chores. So is she gaining that money or losing it? Right, Robin's getting that, right? She's doing the chores. $2.75 times however many days. And this is Wayne, and he's losing because he's paying her. So he's going to do 275 times x. So we've got the two. The question they ask is, when will they have the same amount of money? So in other words, when are they what? Equal. One moment, please. Turn that off. Okay. So we need to then set these equal. So I'm going to take and do 2450 plus 275x equals 6850 minus 275x. Again, lots of solving, lots of opportunity for you to really be meticulous and watch your error signs and not make little errors. Okay? So first thing I want to do is look at my x values, and I want to move the smaller one. So I'm going to move this one. These cancel. I'm left with a 2450 here still, plus, and then what does this give you? It's 4550. X equals 6850. Okay, I'm going to move this over. If you ever need more room, you can always use a sheet of paper. So if you feel like on the test you're crunkled in, just get a sheet of paper and use it. Let's see, this is what, $44? We're going to divide it by 550. And we'll find out now. What is that? 44 divided by 550. 8. Okay, so what is 8? What exactly is that? That's 8 days. When 8 days are up, they have now the same amount of money. Okay. Thankfully, it's one of our options. Okay. Next page. And with that, it's time for a commercial break. We will be having our book recommendation today, and today I am recommending highly this book, Little Women. As you can tell, it is a very fine, fine book. It was my book when I was like 12 years old, probably about your age. And I got this, and it was so nice, and it had the engraving. I remember sitting at my desk and reading this. I was so excited to read this huge book. And look at these pretty pictures, you guys. Aren't they pretty? That's what books used to be like. So nice. See? Oh dear, what's happening? Goodbye, my darling. God bless and keep us all. All right, anyway. And that, of course, is by Louisa May Alcott. Highly recommend that. All right, there's also a book called Little Men, if the gentlemen out there want to have a counterpart. I've never read it, though, so I can't speak to that one. I'm sure it's just as good. All right, back to math. Solve by any method. Okay, so you get to pick your favorite. Graphing, elimination, substitution. Now, when you do this, any way you put it, you're going to want to solve for sure at least one of them for y, but we're just going to go ahead and do both so we have everything in front of us. Okay, so I'm just going to drop down here, y plus x equals 3, 1/2 y equals negative 1/3 x. I'm going to solve this for y. And remember, I always put the x first. So there's one of them. Then I'm going to go over here and solve this for y. That's a little trickier. How do you get rid of that half? It's being multiplied by the y. I know you remember. You multiply by the reciprocal. So let's cross off and give you 1. And I'm left with negative 1/3. Oops, I made a mistake. Get that handy dandy white out, because I'm not using my erasable pen there at the moment. I forgot to multiply it. So 2 times 1 is negative 2/3 x. All right. Can I have a tissue? Thank you. One moment, please. All right. So let's look at first graphing. Okay. Again, this one take you this long because you are going to pick any of these methods, but depending on what you picked. So let's graph the first one. I get different colors for this. So the intercept is 3, so I go up to 3. And Kitty, tell her to be quiet. Which comes in. Intercept is 3 and negative 1, so it'd be it's a negative 1 slope, so down 1 over 1, or up 1 over 1. Doesn't matter which direction you go. But I'm going to now draw my line, label it, do my next line. All these choices, I can't pick. I can use this one yet. What's the intercept here? When there is none, it's what? 0. Oh dear, really? Really? It's not going to work for me? What is this nonsense? 2 pens in one lesson. This is ridiculous. Pure ridiculousness. All right. 3 strikes, we're out. Video over. Just kidding. I'd never do that to you guys. You'd be so disappointed. Okay, so there we go. That one works. My intercept is 0. Negative 3 and a negative 2/3 is the slope. So down 2 over 3. 1, 2, 3. Or you could put the negative again with the bottom one. So rise 2 and over 3. 1, 2, 3. Ooh, this is a little slim one there, isn't it? We gotta extend it all the way out for these to cross. So sometimes you gotta do that. All right, let's see where we're at here. It looks to me like we're about right here as our solving. So that looks like it's 9, negative 6. So graphing be 9, negative 6. All right, excuse me. We're going to move on to substitution, see if we get 9, negative 6 here. I sure hope so. That'll prove my accuracy of my graph. Substitution. Substitution, you're putting it in for the other. So since I already solved this, y is equal to this and y is equal to this, I'm going to then just set these equal to each other, like that. Negative x plus 3 equals negative 2/3 x. Draw my line. Need to get my x's together. Slide this paper up. So I'm going to add x here. So we have a 1 here. So we have a 1, a positive 1, and a negative 2/3. So it's 1 minus 2/3. What is that? That's 1/3 x. Okay, and then to get solve for y, or I'm sorry, solve for x, we need to do the reciprocal of 1/3, which is 3 over 1. So these are gone, and we're left with x equals 9. Well, good. We're on the right track so far because we had 9 up here. So my x is 9. Now we have to take that and plug it into one of them. I'm just going to take this one. Could have taken either one. You can, FYI, go back to the original, which actually I'm going to do because, well, you don't have to, but the truth is if you made a mistake in any, well, it's all going to multiply anyway and be wrong. Sorry. I'll just take the original one though, it's real simple. So we have y plus 9 equals 3 minus 9. No, I'm lying. That's not simpler. I mean, I can do it, but I don't want to lead you astray here. Let's do it as I was saying to do it, using this one. Y equals negative x plus 3. So y equals negative 9 plus 3, which is negative 6. Yay! That one worked. Now, last but not least, elimination. So again, you only had to do one of these. They're set up again here, so I'm just going to put them, well actually we need them in standard form. So here's the first one up here in standard form, y plus x equals 3. And then I need this one in standard form, so I'm just going to move this over here. So I'm going to get 1/2 y plus 1/3 x equals 0, because I moved it away. I just don't like those zeros, I know, but it's okay. Or was it my other hour? One of the hours. Okay, so I need to be able to add and have them drop off. So nothing drops off yet, but if I multiply this by, what can I multiply it by? To get that, if I multiply that by 1/2, and that by this by a -1/2, and this by, that'll cancel that out. Let's do that. This is definitely not the easiest way, by the way. I'm sure you figured that out. But it was a possibility, so I'm going to do it for those that did it. If you multiply it by a -1/2, you get a negative 1/2 y minus 1/2 x equals negative 3/2. Lots of fun going on here. 1/2 y plus 1/3 x equals 0. We're adding straight down. Gone. We have a negative 1/2 and a positive 1/3. Need common denominators. So we're going to multiply them by 3 on the top. So I have a negative 3/6. I'm going to multiply by a 2 on the bottom. So I get a 2/6. We're going to add them together to get a negative 1/6 x equals negative 3/2. Holy cow moly. Multiply this by a negative 6 over 1. Gone. X is 9. Hallelujah, hallelujah, hallelujah. Oh dear. So that worked after all that nasty work in there. But I just want you to see it does work. Again, usually this isn't the best option for when I say pick any. It's either graphing it or substitution. But anywho, let's pick one of them and plug it back in. I'm going to put it in right here. Use that same one. Y equals negative x plus 3. Y equals negative 9 plus 3. Y equals a negative 6. Yay! All worked. Okay, moving on. So when we get to this bottom one, I want you to notice it doesn't say solve. What is the directive? Up to this point, we've been solving, and more solving. We are classifying. So that was the ones with the, we had a couple options. We had consistent. I don't really have room because I need my room on there. Consistent and dependent, consistent and independent. And then we just had inconsistent. Do you remember what the inconsistent was? The one word, inconsistent, kind of lines? It's parallel. And then we had consistent and dependent. And those were when you had two lines right on top of each other. And then you had consistent and independent. And those were just two random lines that crossed in one point, like these. That's consistent and independent. They have one spot they cross. When they're parallel, they're inconsistent. And when they actually lie right on top of each other, they're consistent and dependent. Okay, so we gotta figure this out. We can't really figure it out until we solve for y. Again, I'm going to erase this part now. No, I'm not. Yes, I am. No, I'm not. Yes, I am. All right. I don't know if I've said this before, but I highly recommend these pens. I think I already did a commercial break on these before, so I won't do it again. All right. Solve for y. Gotta be able to solve for y. just going to rewrite them and work down so I don't make little mistakes because I'm crunching it all in there. Divide every term by 5. Over to this one. Solving for y minus 2. Divide by 10. Reduce this though. Don't just leave it like that or you're not going to see the thing. So it's 2/5 x minus 1/5. Okay, so now you can look at these, right? You can see what's true about their slope. Are they the same or not? Slopes are different. Okay, so if the slopes are different, it's not going to be parallel. It's not going to be on top of each other because those would have the same slope too. And the intercepts are different as well. We've got two completely different lines that cross in how many points? 1 point. We have a situation like that going on. And therefore, it is consistent and independent. That is the proper classification. You got to give me both words, and the only time you need one word is if it is the parallel lines that are inconsistent. Okay, which equation would make this system consistent and dependent? This was consistent and independent. Consistent and dependent. That is the exact same line. So how many solutions are there? Infinitely many. Because they overlap. They're all in common. Well, in order to do it again, like we did down here, we had to solve them both, right? We have to do the same thing up here. Solve, 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 solve. So let's do that. All right. First we're going to start with, this is a little tedious for sure. I'm not even sure where to start because I don't want to run out of room. I'm going to start with this one and I'll do them in different colors. So 2/3 y equals 7x minus 1/2. And then we need to multiply by the reciprocal here. So we're going to multiply this by 3/2. Going to multiply this by 3/2. Be very careful because when you're multiplying, you have to multiply 3/2 by both of these. So these cross off and I'm left with y equals 21x over 2 minus 3/4. Okay, so that's the original equation right here. We're trying to match that up. In fact, I'll write that up here. Okay, we're looking for that same equation. Okay, let's do f. I'm just going to write f here. F. Let's try that one. We're solving for y. Solving for y, move the 3/2. That's the easier one. So I'm left with y equals 21x minus 3/2. Is that the same? No. No. Not f. How about g? Let's try g. If we get to the right one, we can be done. Unless you want to double check, then of course you could do that. G, 42x minus 4y equals 3. Solve for y, minus 42x. Negative 4y equals negative 42x plus 3. Divide by negative 4. Y equals, what is that? Divide by 2, divide by 2. So 21/2. Okay. Minus 3/4. Or plus a negative, same thing. Okay, so there's that one. Is that the same? Ding, 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 ding. We have a winner. So we don't have to go and do the other two. But one of them should have been the same. So if you didn't get it, you made an error somewhere. Onward. We're back to this where we're solving. Solving means I want to know what is the point. Or if it's like a point like this where they overlap, it's infinitely many points. Or if they're parallel, how many solutions are there? None. So let's see. Again, we got to solve. Lots of solving on this. I don't know if I said that already. I'm reducing this 4/6, 2/3. Reducing the 6/9 to 2/3, otherwise we're not going to be able to analyze. So here we go. Let's analyze slopes. Oh, slopes are the same. So a slope is 2/3. Same. Oh, let's look at the y-intercept. Ooh, the y-intercept is the same. What does that mean? You are correct. It is the same exact line as you can tell. So if it's the same exact line, how many solutions are there? Just did that. Infinitely many. They overlap. Everything's the same. So you would literally write infinitely many solutions. Okay. Tell whether this is a solution. So we just need to go in here and where is my favorite color? I'm going to use this one. We are going to go in here and just substitute. So x and y and see if it's true or false. But now we're working with inequalities, so be very careful. So we have 7.5 is greater than or equal to negative 1/4 times 10 minus 5. Okay, I'm going to leave this side alone and just work with this over here now. So it's 10/1. And we can cross cancel 2 and 5. So I have negative 5/2 minus 5. And what's negative 5/2 if we put it in mixed? It's negative 2.5, isn't it? Minus 5. So negative 2.5 and negative 5, they're the same. We just put them together. So you get negative 7.5. So the question is, oh, did anybody pick that up? I forgot that. Is anybody yelling at me? That means you're paying attention. Okay, this is greater than or equal to this. Remember, it's greater than or equal. Only one of those has to be true. So if this was a positive 7.5, this would still be true. Are you hearing me? It has to be either greater than or equal to this. And it is. It most definitely is. So this is a solution. So answer the question. Yes. All right, good work. We're getting there. We're almost done. Just 4 more problems. So with that, I will have another commercial break. I just got this from the church library. It's called When Calls the Heart, directed by Michael Landon Jr. And I don't know if you noticed, but they have all these beautiful older dresses, which I love these shows where they have all those pretty dresses. So I will give you an analysis in class and let you know if it's worthy of your time or if you should spend that time instead working on your math. Okay. Solution of what linear equation is graphed below? So in other words, we're going the opposite direction. Although I didn't actually even have you graph a linear equation yet. But if where we do the opposite direction in here. So Remember, this is when I said we'll set it up like this. You have to figure out the two things in here. You have to figure out the slope, and you have to figure out the y-intercept. 4 things. Slope, y-intercept, line, dashed or solid, and shading, inequality. Remember, greater than is above the line, and less than is below the line. Solid is equal when there's the equal under it, and dashed is when there's not. So, let's do it. Is it a solid line? It sure is. So I'm going to have a line under it. Is it above the line or below the line? Looks like it's below the line, right? So it is less than. Intercept, looks like it to me is, let's see, what is that? Is that a negative? I gotta see if it's clear on my sheet here. Negative 18, I think. So put that in there. And then we need the slope. So I gotta find 2 spots where it hits. So here's 1. And then it's very hard to see. I'm not going to make it this difficult on the test, but I grabbed those 2. So when I went up, I went all the way up to 2. Okay, so rise 16 over run of negative 4. There's my slope. So that's a negative 4. And there's my equation. And of course you could have had it like this as well. Same thing. Okay. Tell whether this is a solution. Remember, it's got to work for both inequalities. So we need to substitute it in to both. So y is less than or equal to x minus 4. Negative x plus 3y is greater than negative 4. This is my x, this is my y. I'm going to plug them in and see if they're both true or not. So y, 1/3 less than or equal to 5 minus 4. 1/3 is less than or equal to 1. Is that true or false? That is true. 1/3 is less than 1. So yes. Let's try this one. Negative, now put the x in, 5 plus 3 times 1/3, make sure you put it in parentheses, is greater than negative 4. Order of operations, we got to do this first. 3 times 1/3 is 1. Negative 5 plus 1 is negative 4. Is negative 4 greater than negative 4? No. If this equation had had an equal under it, it would have been yes. But it doesn't. It simply says, is negative 4 bigger than negative 4? No. So be very, very careful about that. So my answer to the question then is no. They both have to be yes, or it's not going to work. Okay, so when we get to this one, we again have to graph, and again, what are we doing? Solving for y. So y minus 3x is less than 5. I can hear that my son is home because the whole neighborhood can hear when my son is home. Okay, so here we go. We got to solve this. I'm going to add 3x to both sides. And now I need to solve this for y. So I'm going to subtract 3x. Ooh, I'm glad this is coming up because wait till you see what happens here. I've got a negative y. I have to divide. There's a negative 1 there, right? So I'm dividing by a negative 1 on everything, which makes this flip directions. So y is less than or equal to, negative over negative is a 3 minus 7. Tricky, tricky, tricky. Don't get tricked. So now we've got them easy to graph. I am going to find, oh yeah, I have the pink. And I'm going to use the pink highlighter. Pink and yellow are the best. So when I plot this, I'm up at 5, intercept. Rise 3, run 1. 1, 2, 3, run 1. My graph is a little dicey here. Rise 3, run 1. So I'm just going to do that to help myself. Hang on 1 second. They're going to come blasting in the door, and I have to just tell them I am indeed recording right now. Andrew, I'm recording. So, draw my line. Oh, shoot. I screwed it up. What did I do? See, I was so distracted. What did I do wrong, class? What did I do wrong? I drew a solid line, whereas it should be a dashed. And that's another reason that this whiteout is fantastic. Watch this, people. I can go like this. Weep, beep, all gone. Now I have a dashed line. It is miraculous, I know. And y is less than 3x plus 5. I'm not done yet because I didn't do my shading, but at least I got the line right now. And it's less than, so it's going to be this side. So I'm going to go right up to the line, not including the line, but I'm going to go right up to the line. And then I'm going to plot the other one. And I'm going to use, I think I'll use the blue. So it jumps off. -7 is my intercept. Is that 7? No, that's 6. Sorry. I cannot see. Now my vision's going. That's no good. Okay. And rise 3, run 1. 1, 2, 3, run 1. 1, 2, 3, run 1. Interesting. This is very, very interesting. Is it a solid line? Yes. I'm afraid it's going to smear, so I'm going to just block those dots. Sure enough, they were going to smear all over my nice picture. Okay. Use a different blue pen. That one is way. Of course, I don't have another one, so, okay. Oh, that's just fascinating. Do you guys see what I see? They're parallel. But it should look that way because what do they have? Same slope, different y-intercept. Got to do my shading. I'm going to use this. It is less than, so it is below the line. Ah, here's where the magic happens. Look at this. I can now see, because I use that, I know, and I'm trying not to touch the blue because it will be a big mess. Try and go right up to it. Oh, see? Sure enough. Okay. So, the solution to these both is everything in orange. Okay, the pink alone here is not the solution for that one inequality, but not at both of them. The only ones that are for both are the part that overlaps, which happens to be the orange, which happens to be all of the yellow. Which one was the yellow? This one. That was yellow. And this was pink. And the solution is orange. Isn't that cool? Come on, that is so cool. So if I asked you for, oh, I do, right here, give two ordered pairs that are solutions, it has to be everything in the orange. I'm sorry, not everything, just two of the ordered pairs. So if we go to here, we're going to go let's see, 6, 8, 0. I'll pick that one. And I'll pick that one, and I'll pick 10, 0. Those are solutions. If I pick anything that's not a solution, it's anything not in there. So I could pick 0, 0. That's in the pink, but that's not a solution. Or I could pick something outside completely, negative 8, 0. And it doesn't have to be on this. It can be anywhere on this picture. For the orange, you could pick any point over here in this whole area. But make sure you read the directions. It asks for 2, not 1. Whoopsie, there, 2. Okay, we're almost there, folks. This one did get a little long. I'm sorry about that. With all the different options, that one problem really took a little time. Class fundraiser is earning $7 per car wash, W. So it tells you the variable. Do you see that? I'm going to use pink. So $7 for the car wash, which is W. And $4 per cake, which is C. The cakes cost 2 to make, and the supplies cost, the cakes cost $2 to make, and the supplies for the car wash cost 1 to make. So they want to know, let's see here, they will wash less than 50 cars. Okay, so the cars less than 50. I'm doing it in pink because what letter was the cars? The W. So they want the W to be less than 50. So where do you see a W less than 50? Oh, in all of them. Okay, so we haven't narrowed any out yet. And they must bake no more than 30 cakes. And again, yellow because cakes is C. So no more than 30. So that means they're going to make 30 or less. Oh, okay. So far, those are the same in all of them. So we don't have anything rolled out yet. It's the money one. So if you notice, this last one on all these is about the money. It's what do they're trying to decide. They want to raise at least $320 to give local charity. Okay, right there. At least $320. How do you write that? That means it could be equal to $320, could be equal to, or more. So for sure, I can rule out a couple right now, at least one, this one. It's not less than, they don't want to earn less than that, they want to earn at least that. So this one's out. Goodbye. And this one, we got to figure out how much each of them costs. So we know W is the wash, and it says here, yeah, $7 for a wash, but, big but, how much money does it cost for each car? Because this is the amount of money they're making off of it. So it's $7 per car wash, but it costs $1 per car for the supplies. So you have to take that off of it. So really, how much are they making? $6 for what? The wash, the W. 6W plus, now let's figure out the cakes. So the cake was $4, but there were supply costs for that too. Those were $2 to make. So how much did they actually gain after they sold it? 4 minus 2, $2 per cake. Do we have that in here? Hopefully, yes we do. Right there, J. So these are not the right answers, just to be clear. This is my correct answer, J. All right. That's all she wrote, folks. Have a great day. Bye.